Hi there. So the next test we're going to take a look at is the guided test for coil on plug probe and non-intrusive touch measurements. So you might be wondering why we've put the coil on plug probe in the EV kit. Well, aside from the obvious test that you can do with the conventional hybrid, so the gasoline engine or diesel, looking at secondary ignition, injector signals, EGR, etc. We can also use the COT probe to look at EVSE signals, or the AC signals coming into the vehicle, which are then obviously converted by the onboard charger into the DC to charge up the high voltage battery. So we're going to go to the guided test. All this is going to do is just load in a preset for us just to get everything set up. So we're going to click on EV vehicles, and then we're going to go to generic tests, and this is a non-intrusive test obviously using the coil and plug probe. So we'll hit guide and settings. Now the EV tests obviously always come with the warning message, so we're going to need to acknowledge that just to make sure that we're all safe and protected and know what we're doing. Now, there's not an awful lot else to this test because it's a bit of almost like a first look sensor we're going to use in this case, just to actually measure any sort of electrical field around the paddle. So we're just going to minimize the guided test, and we've got our preset already set up. So we've got our coil and plug probe, which is already recognized by the software as B&C+. And we've got a time base of 200 milliseconds per division. Now obviously puts the scope into streaming mode, so we can actually see the transition of the waveform as it moves from left to right on the screen. So we're going to start the scope. And we're going to connect our electric vehicle to an EVSE. Plug that in. Now we do have another guided test on this for charging current split, which actually shows you with the distribution of current from the EVSE and how it gets distributed on the vehicle. So we can assume that if this is working, then we should have electrical activity around it. So what we'll do is we'll take our coil and plug probe, and we'll connect it to a chassis ground using the grounding clip. And the first thing we're going to do is just offer the coil and plug probe up to the housing on the Type 2 connector. So you can see there we've actually got activity present, and we can see how that intensity changes depending on the location of the coil and plug probe. And we can also trace this back so that we can actually start to see that even on the cable itself, we've actually got activity. And again, you can see the movement, depending on where the coil and plug probe is, depends on the intensity of the signal coming out. So now we can actually start to use the coil and plug probe to trace the routing of the cabling from the EVSE and the vehicle inlet into the onboard charger. So if I place the coil and plug probe here, which is on the back of the vehicle inlet, you can see how that AC signal is present. And we can follow that all the way around. We can continue to trace it. We have a plug here, so we can place that on there. Anywhere else on the vehicle, you see that actually there's no activity of that AC signal until you start getting into the proximity of a cable. So we go into the vehicle and then continue to follow it round. So we have this cable here, and it's coming down the inside, then follows it round until we get towards the onboard charger. Now, if I was to place this on a DC cable, you can see how actually there's no activity present at all. So it's only on the AC that we're interested in. We continue following it round until we get to the onboard charger, which is here. So we can see the AC being delivered. And if we look at the DC, which is going out to recharge the high voltage battery, you see how there is nothing there at all. So between the two, that's quite clear which one is from the vehicle inlet, which is connected to the EVSE, and which one cable is going to the DC side of the battery. Just to check to see how protected and how insulated the onboard charger is from emitting any sort of AC signals. If I just move the COT probe around the top of the onboard charger, you can see actually there's nothing there. So one final test then, just to show that this is definitely the AC coming in. We actually now pause the charging. You can see how that instantly deactivates. So I hope that helps, and I hope it's worthwhile to see how the COT probe can be used in other ways. And for more information, please visit our website at picoauto.com. Thank you very much.